Can you scroll up? Sandise, can you? Yeah. Okay. Just scroll slightly down. It was just some of it was missing. Some of the Okay, thank you. Good. I'd like to welcome everyone to this session. My name is JJ. I'm the program manager for real-time information management systems at the Mandela Mining Precinct. In terms of introductions, could I ask that everyone just maybe post their name, their role, and the company they represent in the chat box? That'll be an easy way to see who's joined on the session. So post your details in the chat box. And the context and background that I just want to sketch here as before we jump into the presentations is, and I think the presenters are familiar with who we are, because a lot of the companies that we've approached and asked to present are LEO or leading edge collaborators. You know, the leading edge only platform, which is a collaboration network or platform. And how this came about was that over the course of the last 2 years, we posted several challenges on this innovation platform to the LEO community. And many of the community members responded to the challenges by posting information about their companies, their products, their solutions. And unfortunately, over the last 6 months or so, as the intention was to actually reach out to each and every one of them, but we weren't able to do so. So what we did instead was to create these events. And we call them the Dragon's Den pitching sessions, with the objective of not letting anyone fall through the cracks, as it were. So all these collaborators and innovators that responded to us on the LEO platform, we wanted to give them an opportunity to present in this forum. And so the aim of this forum is basically for these collaborators or service providers or solution providers to present their products to our mining community, either with the intention of incorporating these into our programs, our research, development, or innovation programs, alternatively to allow for the mining companies themselves to reach out to you directly. If there is something of interest to them. So, and we just wanted to set the scene and provide the platform in which this could occur. So hopefully that does present a bit of background and context as to why we're doing this. We have another third event for next week. So we've actually held one, and this is the second one. So I want to just welcome the presenters again to this session. Thank you for your time. Could I ask that we just keep to the timelines? They're very strict timelines in which we have to fit in these presentations. So each team will get about 20 minutes, and maybe we can squeeze in a question and answer opportunity after that. So with that, I'd like to then hand over to our first presenter, which is the company Accusys. So that'll be Jack and Justin. So welcome and thank you, and over to you. Justin, we can't hear you. Maybe you're on mute.
Okay, can you hear me now?
Yes. Gotcha.
All right. Sorry, just got back from Germany, and this is the first session I've done since enjoying that wonderfully warm weather over there. So I'm not sure where the jack comes from. I can guess, probably one of our suppliers, but my name's Justin Tweedy. Hopefully you can see the display. Let me get up my presentation for you. And you should be able to see our presentation.
Yes.
All right, excellent. Thanks so much for that and the opportunity. What I'm going to do is just share some slides with the technology. It's been in the marketplace for some time. We've actually got a fairly large footprint in the mining industry and other industries, but I'm going to be focusing on the mining industry. And the product in particular is a product called Octoplant, previously known as Version Dog. Some people may know it by that name. And the focus really is understanding how we manage OT systems and automation in reducing the risks related to that in mining operations. So if we look, mining and modern mining today really relies on OT systems. There aren't mines effectively without automation. And we see a continual increase in digitization, resulting in increased complexity of those systems in most mining environments. Without a doubt, OT systems and changes to OT systems do impact on equipment. Regularly, we hear of cases where there have been losses of equipment and unfortunately sometimes life associated as well. So safety is a key component. And in most mining environments, it's a situation that obviously would we lose any of these key assets, we lose production immediately, never to recover that again. So OT systems rely heavily also, and we see this a lot in the African region, on external service providers. In very few cases are the services on site. So you've got a complex environment of on-site and off-site services working on these systems. As we know, day to day, the probability of cyber attacks increase. And we again see more and more focus on that. And how do we prevent the risk to automation systems relating to that? One of the other things we are aware of is that governance in the OT systems is not nearly as strong as in IT systems. And often that's where a customer will engage with us when they've had an audit. One of the large audit houses come in and identify the risk relating to the backup and recovery of OT systems to the business. So just a quick introduction. Octoplant it's a top of class data management platform, and really the focus is all automated production assets. So all your assets in the OT environment. And the idea is to improve visualization and analysis of that OT backup and monitoring process. Today, in many situations, we get to site and worst case, someone's got it on a little memory stick. They've got their backups. In some cases, I've been told that, sorry, the guy with the laptop's not here today. And you know, it's almost unbelievable that you've got these large assets worth hundreds of millions, and yet that is the situation. Most often, or not most cases, there is a central backup of some sort, but often there's not very much management associated or tooling around management of those backups. And then thirdly, it looks at providing a mechanism where we can introduce cybersecurity in the OT environment. So looking at the various devices in the OT space, Octoplant supports more than any other product globally. And there can be a number of different devices in South Africa and Southern Africa. We see primarily the Siemens devices, but there are a number of other drives and various components, robots, SCADA systems. And so as you can see, it's a fairly complex environment. On our supplier's website, I've included a link in this presentation, and we'll make the presentation available. You can actually go up and look up for certain devices if you've got anything in particular that you want to see whether or not we do provide support for that. So the typical scenario and the question that everyone asks is, regarding OT systems, when something goes wrong, who changed what, why, and when they changed it. And really what we're seeing out there is, without any formal systems in place, there's almost no visibility as to what's happened. An external provider can come in and make a change to a device, and at the same time he updates an unrelated system, and no one on the site would know until something goes wrong, and then the inquest begins. But it's very difficult to really monitor across all these different devices when things have changed and what changed and who changed it. As soon as there's a failure or loss on a device, obviously that impacts on production. And the first question is there a backup? And the hunt begins. You know, you look in the cupboard, you look on the drive where all the backups are, and even then trying to identify which is the one that was running in the field at the time of failure can be quite difficult. So the question is that program that we're trying to recover the same that was running in that device? So changes have been made, improvements have been made. There are productivity gains that are being gained. And then when we get that failure, are we sure that we're going to recover exactly what was in the field? And that's difficult to answer without any system in place. How quickly can you recover also relies on how sure you are that what you've got as a backup is the same as it was already in the field. If not, there can be risks related, and I know of a number of horror stories where in one particular case there was a furnace explosion. This was about 10 years ago, relating to the recovery of automation software and loading in the incorrect one. Just recently there was in the petrochemical environment, there was an oil well that went up in flames, also related to a similar incident. One thing that we don't see at all is device changes being monitored. So are they actively being monitored? So how do we see when something's changed and detect those changes across all the devices in the field? And then is there a record of what those changes are? You know, changes made to these devices generally are done to improve efficiency, improve extraction, make some improvements in the production process. And often those changes may have a negative impact, they may have a positive impact, but how do we understand that history, the record of all the changes that have been made and how they impact on production? So keeping a record of that's obviously important. And then a simple question, are the devices that we have on the current firmware? You know, looking at the cybersecurity aspects. So very simply, what Octoplant does is it provides a central storage mechanism. At any point in time, any user can check out the latest version of the software to get it on his machine. They make changes and download that to the device in the field using their normal engineering software. Once they've completed that process, it provides a mechanism then for them to check that into the central server with the comments and reasons why they made the changes. So we provide a formal procedure on top of the editor, the standard OT device editor software, and allows users to capture this information. On a scheduled basis, there is an upload from the devices, typically each shift, and then we can compare that to what was in the device on the previous upload, and that way monitor for changes in the field across all the devices. So very, very simply, this is a screenshot of the software. It enables you to record capture all the assets, all the device assets and the projects related to it. We can then set up schedules for safeguarding, as I say, typically a shift, so we can identify in what shift changes were made. We can configure notifications so that responsible staff receive notifications of changes made to devices. And as you can see, there's a graphical comparison provided. You can see exactly what those changes were. So changes, once you receive notification, you can go and determine what the changes are, and it quickly identifies that for you. Here again, you can see the differences before and after changes are made, and again, very clearly identifying what changes are made. So it really allows all staff to get information about changes and without having to go and hunt to see what has changed. And then you get an overview, a clear 360 degree of all your assets. So one point that you can go in and look at all the assets across the enterprise and see what is the status of those assets at any point in time. So we break that up, obviously, either geographically, so you can filter and you can go and select and look at the different plant areas and see what the status of devices there. Another typical example is if you have issues that are occurring, usually the first point of call is to go and investigate the automation, to understand what's changed there that's impacted. And this allows you to very quickly look into a plant area and see if there were any changes made to automation in that area. And then, of course, recovery is really as simple as selecting the asset. And we have automated scheduled backups of that you can, from a click of a button, recover that back to the project folder and, of course, reload or restore a device in the field. So it's a very simple application, but it provides this central view and the visibility that's not typically there without it. We have web reporting, so you can come in and look at the detail of all your assets. Here's a list of various assets where we can see the model number, the firmware versions, and with that, the ability to do lookups against a CVD database. So look at the common vulnerabilities, what has been exposed on that particular firmware, so that we can understand where we need to change or update firmware in the assets. And then again, further monitoring, green obviously being what we're trying to achieve, making sure that everything in the field is backed up and we have a current recovery. Blue where there are differences, and if there's communication areas, we can see some red indication here. But very clearly across all the assets now, we have a way of seeing how well we're performing with regards to our backups and how ready we are for recovery should something go wrong, as it typically does at some point in time. Just to give you an idea of some of the companies already using the software, we've got 14 years of experience in providing this in this space. And as you can see, it's a fairly broad selection. These are all in the Southern African region, ones that I've been directly involved with myself, but I guess we have others elsewhere in the world as well. I know there are implementations in Brazil and many in the Australia area as well. So I hope that we haven't gone too much over time or too quickly, but I would rather give you some time to ask questions. In conclusion, really, what we're looking at is a single solution for all OT software. So anything related with its devices, whether it's the configuration files for drives, whether it's SCADA systems, it's a single solution that can be applied to all. And then enabling visibility of all the changes, something which we don't typically have without this system. And the ability to go in and understand what has changed. It's just really at a point now with the number of systems we see in the field, it's almost impossible to do that without a formal system in place. Making sure that we have an effective, dependable source for recovery. And then one of the things, just out of information, I didn't cover it in the slides, but typically the implementation of the software can be as quick as 3 days to 5 days. So it's a really, really quick implementation, training the users on the site, enabling them to then include the asset backups over time. And then, of course, reducing risk is the key focus, so improving safety and production availability. So I shot through that fairly quickly. The product again is Octoplant, and if there are any questions, just shout. Those are my details, and we can, of course, provide, we do pilots on sites. We can provide a more detailed overview of the software and the technology as well.
Great, thank you, Justin. Very interesting solution or product. I think the benefits speak for themselves. Does it have, I'll kick off with the first question. So anybody who has a question, please put up your hand or post it in the chat. But in the meantime, Justin, the question from me is, does it have auto discovery of devices or systems that monitoring in the mine or in the plant? Does it have auto discovery of what you have out there, especially for the older sites, legacy sites, legacy machines?
Not currently, although it has been something that they have discussed. They do provide a mechanism where you can import the configuration and an asset list and then work against that. But typically these plants can be quite segmented. Often the network's not all accessible from a single point. So there is a process that we go through of identifying and configuring, and it's surprisingly quick. In many cases, we'll be able to get the complete mine configured and running, as I say, within a 2 to 3 day period, which is quite fast. But this is an ongoing thing, and as the software is deployed, users can continue adding in different things, different systems, even backing up things like workstations, doing drive imaging. So it really expands as you add in the new devices.
Yeah. And would it be useful in the mining extraction side of the value chain as opposed to, let's say, a processing or a plant? Do you have applications on that side of the value chain?
Yeah, I mean, well, wherever there are OT and automation devices present, obviously that's being the core focus. So, a number of these sites that I showed earlier would have both an underground activity and a beneficiation as well. And, right from the raw material through to the final export. Yeah.
Great. Thank you very much. I don't see any hands. Are there any other questions from the audience? I see a number of our mining colleagues on the call. Great. But Justin's contact, Fritz, I see your hand.
Justin, just correct me if I'm wrong. Is this the evolution of version dog, or is there?
Correct. Yes, it is. It is the evolution of version dog. They've expanded the solution quite significantly, and it has moved to subscription, like many of these applications, with an interesting roadmap moving forward. So as we were saying, there's no doubt that this environment is getting more and more complex, and that's not going to change.
Thank you.
Thanks.
Thanks, Fritz. Good. Thank you, Justin.
Thanks so much. Appreciate the opportunity.
Yes, thank you. With that, I'd like to then continue with our next presenter. It's a company, Mine Spider. Very cool name. And I think it's going to be presented by Christian, Ella, and Nathan. Is that correct?
It's 1/3 correct. Hello, everybody. I'm Christian. I'm going to be presenting myself on behalf of Mine Spider. Let me just go ahead and share my screen. Here we go. All right. Can everybody see that? Let me just maybe move it to full. Let me move it to full screen, maybe. So good afternoon, everybody, and thank you for the opportunity and for organizing that, JJ and everybody else at the Mandela Mining Precinct. I'm Christian. I'm with Mine Spider here, presenting for us, and I'm leading our upstream projects, so our mining and metals engagement. I'd start by talking a little bit first about, very briefly, our company. We were established in 2019 or 18, sorry, I joined in 19. And basically with the vision to work towards a world where tracked responsible products are the norm rather than the exception. So what we are providing to the mining sector, to the mining and metals industry at large, is a software that allows companies to collect, to store, and to share data along the supply chain. So in the mining and metal space, but up until the OEMs, right? So we really want to work with companies to understand, collaborate with, and transform the supply network. So what we do is basically we enable those companies to collect and share data and to pass on that data, right? So it can go both ways. You can pull data from your supply chain or pass data towards your supply chain to give transparency about what you purchase and the ability to distinguish your products in the market. We do that because data is increasingly necessary to do business globally, from the mine to the end product. And basically, we're doing that with our plug-and-play traceability platform that we built on our low emissions blockchain. So what I want to do now in this, in the course of the next 15 to 20 minutes, is first give you a brief overview of our product offerings, so what it is that we're doing, and then talk about a few example projects that we have just very briefly, and then I would open it up to your questions and comments, of course. At the core of what we offer, what MinesBetter offers, is a technology platform, right? So it's a platform to, in essence, create product passports. I will get to that in a second, which are essentially data packages about a product, right? So in the mining sector, this could be a certain unit of ore, it could be ingots, it could be rods, whatever the material is. It's there to store data and to keep track of in and outgoing shipments. It's a web app, so it can be accessed through the browsers, both on a desktop and on a mobile phone. At the moment, we offer it in 5 different languages, although we are adding more depending on our customers' needs. And as I said, it collects and stores shipment level data. However, it's also there to save and organize company level data, right? So typically this would be audit report, mining licenses, and export certifications, all those sort of things. In the platform, a big benefit of that, or service we offer to our customers, of course, through that, is the organization of data. So we have in there actually a set of standardized data templates tailored to certain regulations, certain reporting requirements, but at the same time, of course, we can tailor and customize that to the need of whichever company we're working with. And I should also say that all of this can be integrated via our API, application programming interface, and also via file integration, so to upload or download Excel sheets, for example. I mentioned product passports before already. Product passports are essentially data packages. And those data packages a company would set up for a certain product that you're selling, right? So for example, if we are in the mining sector here, we take a shipment that leaves the mine site to go to a smelter or to a trader. A mining company would then create a product passport, which is a data package containing all the information that is relevant to communicate with the receiving company, with the client, or maybe also entities in between, like border controls, for example, right? So all the data goes into the product passport. You use it to demonstrate proof of provenance, to show the key product and compliance data, but also we have companies that use that to brand products, right? To show the responsible provenance, to distinguish them on the market. And you can access those product passports either via your platform, by your Access account, your web account, or alternatively, whenever you create a product passport, you automatically generate a QR code that our clients then can print out and attach to the shipments, to the container, to the physical product, or simply on the invoice, for example, or any other paperwork that's accompanying the shipment, depending on the level of digitization, of course. Now, those product passports, initially I said we are working on traceability along supply chains. Those product passports can be linked together and added up on in the course of a supply chain. So if we're talking, for example, mine site selling something to a transporter or to a smelter, the example I just mentioned, they would add a product passport here, right? And the smelter takes the ore, for example, right? And they do what a smelter does. They take the ore, they process it, and then they're selling ingots. They would set up a product passport for those ingots, including all the information that they need to communicate about those ingots. And then they can link back the product passport of the mine site. So they pass on their information as well as in the information that they received from their supplier, to give the purchaser, in this case, again, trader or transporter, the confidence in the responsible procurement and provenance of that, and all the data that they need for legal import-export to prove or for any other compliance requirements that might be there. Now, it's important when you look at that of course there's always data that shouldn't be or can't be shared along a supply chain, right? Because there is commercial information or information that might otherwise be sensitive. So what we developed for that is basically a three-layered structure for those product passports. So every product passport has 3 data layers: a public layer, transparency layer, and a private layer. Public layer is easy. Public layer, there goes information that's supposed to be visible publicly. So for example, data that when somebody scans that QR code I mentioned before, you would like that person to see, right? So imagine anybody can scan that QR code, right? Imagine you put it on the container, it sits somewhere in a dock worker or a customs agent or whoever comes along, scans the QR code. They would be able to see that public information. The private information is information that's only supposed to be visible between the sender and the recipient of a shipment. So again, if we look here, from the raw materials to the transport, for example, the information in the private layer would only be visible to here, the mine and the transporter. And that is usually where commercial information is communicated, right, or contractual details. And then in between, we have the transparency layer. Now, that is the most interesting one if you're talking about communicating data along a supply chain, because the transparency layer is visible along for everybody that receives access to a product passport. So if you go back to the example that I mentioned before, we have a smelting company, a smelter, that they produce ingots of a certain material. They sell that along with a product passport and link the product passport that they received from the mine. The smelter's customer would be able to see transparent and the public data that the mine site provided. And that exercise can be done and continued along an entire supply chain, along a segments of a supply chain, right? And when I towards the end briefly talk about our existing clients and projects, or some of them at least, you'll be able to see that we work with companies at different ends of the supply chain, right, or different stages of the supply chain. We offer all that along with consultancy services. So we have that technology that we built on our own blockchain. Aside from our technical expertise, we also offer a consultancy, particularly in the regard of regulatory compliance. So we mapped about 800 global supply chain laws since our existence. We're working on more. We have a very experienced team. We're a very international team. We operate with projects and clients on a number of different continents, different areas in the world. And we also have quite some experience working with bodies such as the European Union or the United Nations on different topics. So what we usually would offer is consultancy on, as I already mentioned, regulatory compliance, to get companies ready for compliance, to support them in compliance, responsible sourcing requirement, import-export. We offer help in carbon footprint accounting. There we have additional partners that we can bring in, consultancies that are specialized in this topic. And on top of that, also incorporate sustainability branding. So all of that is usually done through a combination of consultancy and tech. And I'll focus the last about 5 minutes on how we work and some of our existing clients. So usually the way we want to work with companies is really taking those thoughts or those headaches away from them so they can focus on their work, like digging minerals out of the ground or smelting ore into ingots. And we take care of helping them to implement the software and the know-how for compliance and communication, right? What we usually do is we usually start working with companies on a pilot project, for example, focusing on one production line, on one type of material or product, and then expanding the use, right? We often also start with a workshop or trial phases. And as I already mentioned, we offer consultancy, software, either or both. We really tailor that to the needs of our clients. 2 example projects I want to point out here. So we've been working for a number of years now already with a Luna smelter in Rwanda. Luna smelter is a tin smelter in Rwanda. And we started working with them in order to provide them with a tool to demonstrate compliance with the EU conflict minerals regulation. Tin, as most of you, many of you would know, is one of the so-called 3 Ts, tin, tantalum, and tungsten. Therefore, falls under conflict mineral regulation in the European Union and in the United States. Therefore, additional reporting requirements apply when you want to import that in one of those areas. And so basically, Luna Smelter has been using our tool to collect and share information that is necessary to demonstrate compliance with that. And they've been gradually expanding the use to digitize and streamline also existing reporting that they have. Another project I just want to mention is gold traceability with a company called Phoenix in Brazil. I know that gold is also, of course, a very important and dominant commodity in the South African mining sector. In Brazil, we cooperate with Phoenix, a gold aggregator, as well as Minery, which is a company that offers mine site audits and ESG scorings, particularly also in the Brazilian gold sector. And so basically, the roles are that Minery is going there to register and to audit or score the mine sites that Phoenix is sourcing from. And then MineSpider's role is that our platform serves to collect all the data between the mine site and then the final gold bar that is being sold to create the chain, that proof of provenance, to demonstrate that the gold comes from legal sources. So along the way, all the legal requirements about environmental audits, mining permits, etc., would be collected. So the customer then has the assurance that this gold, has a legal background, and because as we know, there's a lot of there are issues with illegal gold sourcing from the Amazon, for example, in Brazil, right? Some other, I mentioned before that we also work with companies at all stages of the supply chain. For example, we also work with Google, with Ford Otosan, Renault, and Cisco, also in the context of some European Union grants. I would say that in the downstream side of things, we are very focused at the moment at EV batteries and battery materials, and generally speaking on everything that's considered a critical mineral, either, for example, in the European Union or in the United States, among others. Just so you have a brief picture of our team, as I said, scattered across different countries, speak many different languages, a lot of different backgrounds from compliance, legal, tech, of course, and commercial. And that was it from my side for now. And I think, I hope I am in time still, and I'm looking forward to y'all's question now.
Great, thank you, Christian. Yeah, absolutely good timing, good use of time. In fact, you have extra time. Any questions from our audience? So this raises a number of questions for me in terms of ESG. And what we have found is that there appears to not be a uniform or standard ESG reporting framework. Mining companies tend to adopt one for themselves, and that's what they report against as long as it meets the key parameters and criteria. So how do you decide then what framework to develop or include in your platform?
That's a good question. And I mean, the mining sector is very international, right? And different jurisdictions will always have different expectations. So if you have a mining business and you export to 3 different jurisdictions, you might have 3 different reporting requirements from your clients that you need to that you need to take into consideration, right? The way we are dealing with that is that we don't necessarily decide for our clients which one, like we don't tell our clients, look, implement this reporting scheme, right? We are happy to give advice when it's demanded, or when we're asked for it. But essentially, this goes back to what I talked about, data templates. We have a certain number of, standardized data input templates there. They are usually informed by our already existing clients, but the platform is very, very flexible, and uploading or creating new input fields, input guidances, is really a matter of depending on how expensive they are, a few minutes or a few hours, right? So if a client of ours called me up today and tells me, look, I need reporting requirement against X standard, I would, ideally, if they already sent the questionnaire or the different data fields, I could start setting that up, and then by the evening they would probably have it, depending on, how extensive it is. What we also would do sometimes is that clients are not exactly sure how to report against a certain standard, right? So then this would fall under the consultancy, where we sit down together with them and look at, okay, you have X, Y, and Z reporting requirements. Maybe there's some common denominators, right? Maybe it varies at some points, but how can we help you to gather that data most efficiently and communicate it as effectively as possible?
Okay. So would I be correct in also in saying that your platform ensures that there's a seamless thread of data between typically siloed functions like environmental, social, and governance or risk, that it creates that platform where there's the seamless sharing of the same data, one source of truth? Yes,
that's something that I would certainly hope is true for our customers. In the end, it depends, and it's certainly possible to implement with this platform, right? In the end, it depends a bit. So we work, for example, with companies that are relatively mid-sized, and where for them it's very easy to bring like 3-4 people around the table. Like, okay, this is what we have in terms of environmental data and social data and governance data. Okay, now let's put that all together and have one reporting screen, right? And the platform's perfectly capable of that. When data is siloed within a company, the question is, how do you break those silos and get it together? And then MindSpider's platform can be a place to unite all that, right? As I mentioned, we are able to integrate to different existing systems and, to adapt to different reporting expectations. So what you could also do, for example, set up different data sets on the platform, so to speak, for an environmental or for a social audit, for whatever it is. And then when you send out a shipment of ore or whatever it is, you just select the different data sets that you want to travel with the shipment, right? So you see maybe, okay, this goes to the US, so I select US requirement A and US requirement B, and it goes in. And so in that sense, yes, it would certainly help to unite and streamline those silos.
Okay. Interesting. Great. Any questions, comments from our audience? I think with the proliferation of critical minerals, this is going to become probably something that's a company would have to comply with. I'm just making that statement. I don't know what your views on that.
No, we see that already, right? So, for example, I mentioned conflict minerals, that there have been reporting requirements in place for a long time. We see now the battery regulation in the European Union, for example, that stipulates reporting requirements about the provenance of certain input materials, lithium, nickel, cobalt, and graphite, where purchasers have to prove they know where it's coming from. And we see that on the way for other. We see, for example, the Uyghur Forced Labor Act in the United States, right, where actually you have to prove that it is not involved. If you import silica, for example, you have to prove that it did not involve Uyghur forced labor, right? So you have to proactively show, look, this is where it's coming from, in order to avoid the suspicion. And on the other hand, I think that it's also going to be more, depending on the mineral, more and more commercially viable to do that, because, for example, I was mentioning gold before, right? So gold companies are able to charge a premium of jewelers, for example, if they have jewelers customers jewelers as customers that value responsibly sourced minerals, they can charge a premium if they can prove where it's coming from, right?
Great. Christian, thank you very much. I don't see any questions or hands, so I think it was very clear.
Thank you.
Very interesting. Thank you. Ladies and gentlemen, with that, our next presenter is Tim Alshik and Simon Jack from, I hope I'm pronouncing it correctly, Nebulae. But over to you.
Thanks, John. Yeah, it's Nebulae. Actually, Simon can't make it today. Somehow he decided to catch COVID. Don't know how that happened, but there we go. Thank you very much for organizing this. It's really great pleasure to be here. Let me just make sure you can see my presentation.
Yeah,
can you see this?
I see it. It's not in presentation mode though, but I can see a presentation.
Sorry, you broke up for a second.
It's not in presentation mode.
Is it now? Can you see the transition?
No, it still shows me the navigation bar on the left.
Right, let me just press play. Is it in presentation mode now?
No, it's the same, but I think we can read it. It's fine. It's legible. Yes.
Okay. Let's see if I can increase it a bit more. Right. So we are from a company called Nebulae. It's a British company. We were founded in 2019. But the work behind Nebulae is something that's been spanning for probably a couple of years before that. And it's really involved what we call augmented intelligence, which is basically artificial intelligence that doesn't only focus on machine learning, but we focus exclusively on how do you combine machine learning with human learning to achieve the ultimate intelligence. And part of the reasons for this, because my team, including myself, we've been working in artificial intelligence for a long time. I personally started in the field of AI since 1998 in biotech. My main background is in medical science, so I used AI and data mining technique to decode animal genomes at the time. So we've seen pretty much a crazy evolution of AI, and we feel that at the moment there's far too much hype than reality when it comes to AI. And in fact, this is why we created Nebulae, and the way the company is operated is that we are highly independent. We're very proudly and unapologetically have no VCs. We're fully self-financed. I personally am a tech entrepreneur 20 years, so I've been through the whole process of raising VC funds and stuff with my other companies. And one of the things that I did not personally like is the fact that the way it usually works in the tech world, that unfortunately you have to prioritize your shareholders over your customers. And when it comes to AI, this is actually very dangerous. And this is why we made that decision, myself, my co-founders and the team, to make a company an employee-owned company, so that effectively we're focusing on how do we use AI and from the form of augmented intelligence to serve people first, rather than anybody else, including, of course, customers, employees, and even our own employees as well. And the team behind Nebulae, I'm very proud to say there's a very, very highly experienced team, including our mathematicians, who are led by Professor Alexander Gorban, who's the most cited mathematician in the world. And we're still growing. But as you can see, the variety of our experience doesn't involve just the maths, but also human psychology, human behavior, because this is part of the way of us understanding how human intelligence work to make sure that AI effectively works in harmony and in symbiosis with that. So what we tend to offer, generally speaking, is really more to do with the AI infrastructure. The beauty of being independent, I can be honest about the good and the bad and the ugly side of AI. So AI in itself can never be productized. It's not a product. It's more of an outcome of the infrastructure behind it, specifically your data. We've already seen a couple of the presentations that so far, the amount of data involved in all sectors, mining included, of course. So where is the world moving to now today with, of course, with large language models, is the fact that we're moving in a direction where anyone regardless of your background, your maths capability, your development capability, can access powerful AI tools that can communicate with data. So this is really where the positive aspect of AI comes in. It's like, is the fact that in your organization, anybody, from junior employees all the way to the CEO, have access to your data in a very sort of easy, interactive way through large language models. And this is where we try to transcend the hype from, whether it's going to take over humans or the Terminator will evolve, or whatever. That's all just Hollywood stuff. Let's forget about that. The reality is it's not really that intelligent, but if you involve human in the loop, and this is really kind of the model that we tend to focus on, you can actually create some really, really powerful interactions, which I'm going to demonstrate. And basically, this is where Nano, which is our generative AI chat capability and knowledge discovery platform, comes into play. We actually launched the public version of that, as you can see, is nano.nebula.com. I invite everybody to use it. It's a personal companion. It's kind of like a public offering that we have, whereby it is a responsible, safe sort of chat GPT alternative, as it were. You don't need to register. It's free. Anybody can use it. The idea behind it is that we want to make sure that more and more people use it to give us feedback on how can we push forward with more responsible, safe communication with AI and people. So this is basically for you guys to try if you want. But the enterprise edition of Nano is also built on our language model called IQ, which is specifically designed on top of highly cited and specialized content. So basically research papers, internal sort of enterprise data. And the idea behind it is that we want to make sure that the provenance of the data is as clear as possible and is cited, because of course the danger of AI, not just with large language models, but AI in general, is always the so-called hallucinations, that it just tends to make stuff up. So our priority when it comes to knowledge discovery is to make sure that it hallucinates less and brings you the real facts first, and is cited. And again, I'm going to demonstrate that sort of in a very simple demo later on. But this is really sort of the core engine behind Nano and behind the knowledge discovery platform that we have. And the way we tend to work with organizations in general, as I said, going back from the infrastructure perspective, the ultimate outcome for AI, I mean, the thing about AI, one of the reasons why I said that AI is not as intelligent as people say it is, because it is entirely dependent on the data input. So it is literally sort of a garbage in, garbage out type scenario. So you can have the most amazing algorithms in the world. If you don't actually give it the right data, it will just generate complete nonsense. So the quality of AI is not actually in the algorithms, though they are important, but it's the quality of the data. So all the work that we do with our customers, that we focus relentlessly on the sources and the quality of their existing data sets, but we also help them source external data when necessary, but also we build and construct rather synthetic data to basically train the models around their specific needs. So for instance, with something like ChatGPT, it is a great product, it's really powerful, but it's quite generalized, but also they are running on a shared infrastructure, meaning that whatever prompts you put into it, it is literally shared with the ether. So, you probably saw in the news, Samsung developers, they shared proprietary data and developed some of their code with ChatGPT without realizing it. Actually, it's been accessed by God knows how many millions of other people. So we don't obviously agree with that. This infrastructure that we built for our customers is private, it's exclusive for the customer. And this is where we add the capabilities like the data clustering aspects from the existing data. We do what we call knowledge embedding. So this is where the IQ side of things come in, where we look at the external data sets that could be embedded as a knowledge base and knowledge graph within the existing infrastructure of our customers. And then we integrate parameter efficient tuning, which is basically we tune the language models for it to be as relevant to your business as possible, rather than being generic. Like, in mining, for example, you don't really particularly need to know recipes, chicken recipes or something like that. So this is quite irrelevant. So this is the part of the work that we do in order to generate, as it says on the slide here, safer output generation for higher relevancy. I mean, this is absolutely critical for the enterprise. So the service that we tend to offer, it's in two tiers. It's fairly simple. So the Nano Enterprise, which is basically what I'm describing in here, but it goes alongside of a scheme we have called Client Lab, which is basically an R&D extension of your company. So if you're an enterprise and you want to get access into AI capabilities and data scientists, etc., we can be basically your dedicated research team for AI and data models. And even if you have existing data scientists, like for example, Nestle, we work very closely with Nestle. They've got loads of amazing data scientists, but they still utilize our capabilities because of our level of expertise at the very high different verticals. So with Nano Enterprise, effectively, as I highlighted earlier, we like to focus a lot on the data strategy side of things, because it's not just about the data that you have right now, but where are we going in the future? As we've seen in the previous presentations, we are moving in a very highly data-driven world. So, and this is not going to change. And in fact, we're going to be seeing more and more data coming in, especially from generative AI, funnily enough. So what is the strategy to navigate that? What is the strategy for your business sales? What for your business operations? All of these things are put into consideration as part of the infrastructure. And I should emphasize that we don't build infrastructure from the ground up. The infrastructure is already there. Most of it, if you like, the manual work involves the data strategy, the data pre-processing aspects of your data. Once this is done, which tends to be very complex actually, that once we put it into the infrastructure, then we can deploy the infrastructure with customization of the Nano interface, and basically we take away from there. To give an example of the power of knowledge discovery, we worked with the University of Leicester a few years ago, where they had over 30,000 internal research papers. And one of the things that they wanted to find out, is it possible for them to discover new funding opportunities? And what we've done with the help of Nano and our capabilities, the fact that now that they've discovered opportunities, they've discovered interdepartmental opportunities where their maths department could work closer with their molecular biology and the genetics department in new projects that they didn't think they could do before. So now they actually had the opportunity to apply for new funding that they couldn't apply for before, or well, they weren't even aware of it. So this is the whole point of idea of knowledge discovery. And this just gives you an example of how we can basically, build the knowledge base around your existing data sets. We didn't have to add anything extra there, but it worked out really well. And it's only with 30,000 research papers, which is pretty remarkable, because usually people always talk about, 30 billion, content parameters and stuff like that. You don't really need as much data as you probably think. So this is really the power of knowledge discovery. I think I'm going to try to do a little bit of a demo. So we created the demo version of Nano, they specifically for Mandela mining. So let's see if I can launch this. So I'm going to share that. Can you see the window?
Yes.
Right, so let's see. I literally have no idea what it's going to say, because obviously it's generative AI in this case. But what we've done very simply, we basically told it that this is the version of Nano that works exclusively for Mandela mining. And we injected with basically small latest news, for example, from the conversation. So hopefully it should see it. So if I say, what's the latest mining development news? So now it's basically gone through the IQ data sets before it started going into the LLMs that we use. In this particular example, we're using GPT 3.5 Turbo. And as you can see, it listed all the news that we've injected to it today through the knowledge management. But also, if I say to it, for example, what's the source of these stories? It should tell us that it's from the conversation. And the live version of Nano is actually much quicker than that. As I said, this is just a demo, like it's a very simple implementation. It's still searching. But this is not also, in terms of from the UI and the UX aspect of things, this is also, like I said, we try to make things really simple. Okay, seems to have lost it there. Right, there we go. So This one obviously doesn't have access directly to the internet, but from the knowledge embedding, because we provided the citation of the articles, basically it knows what to look for. And like I said, we don't allow it to basically generate fake URL. So for example, this is the actual URL of the conversation, as you can see. So, and one of the elements, the cool things that we like to do with Nano, that we use something what we call prompt commands. So for example, this is the standard one where if you put a command like help me, it gives you basically how to use Nano. This is something that our Nano companion has as well. But for example, you can actually we can create customized commands. So in this case, for example, if you put Mandela, it actually gives you, obviously this is just a sample, but we can put whatever you like into there. So for instance, whether it's your policy updates, any urgent announcements, or indeed literally you can add anything. So, the sky's the limit. And of course, we're using it sort of in the geeky way here, but it can be, interacted through buttons, for example, or apps. So this is just the idea of what I said earlier, that our priority is how do we make it really that simple for users of all technical abilities, or even with no technical abilities, to interact with data in a really, really complicated data in a really comprehensive and informative way. So I'll go back to the presentation. And that's basically my details. So as I said, if you want to play around with Nano itself, the generic version of Nano, there's more for everybody else. You can play it in here. But for the details for the enterprise edition of Nano, it's at nebulai.com/nano. But if you have any questions, there's my email there. You're very welcome to get in touch anytime. And yeah, we'll look forward to explore this opportunity together with you. Thank you very much. I hope I'm in time.
No problem there, Tim. Thank you very much. Interesting stuff. We have a question in the chat box from Timu. Having a rate in cyber attacks in the business sector, probably given the rate of cyber attacks in the business sector with this AI, is it able to detect the cyber attacks in the business?
Yes, there's actually quite a lot of research on that, because funnily enough, with cyber attacks, the thing I'm quite surprised that I'm not seeing enough the media outlets talk about that. There's a lot of cyber attacks that are powered by AI. so literally I can't remember which research paper recently that somebody highlighted how you could hack machine learning algorithms with machine learning algorithms. So it is actually a very serious problem indeed. In fact, one of the things we've done recently, we advised the UK government's Office for AI, and that is sort of the biggest concern. How do we basically protect systems from such cyber attacks? And that's the reason why we really focus on the private element of the infrastructure. So we don't like, with OpenAI, they chose to have this sort of very kind of like open shared infrastructure. We don't think that's a really good idea. That's why we work with Microsoft, like in building private infrastructure to make the security, much more comprehensive. But also it allows us to add more safeguards. We have no idea what sort of safeguards OpenAI has added, but on Nano, we know the safeguards that Microsoft has added, because we've built it in partnership with Microsoft, but we also added additional safeguards through IQ as that additional safety layer to make sure that it's as safe as possible. So that's basically, how we tend to operate with the security side of things.
Yeah, I think besides pure cybersecurity and threat management, there's a real issue of AI and ethics, and and so how do you deal with it in your solution here? You mentioned earlier on that you have a team of psychologists, which I assume would be industrial psychologists.
More consumer psychologists, more at the moment. But we work quite closely with different universities that basically gives us access to different experts as and when we need them. But now we focus predominantly with consumer psychologists, because you see, the other thing, talking about the ethics of AI, one of the things that you can do quite easily with AI, surprisingly, is change people's behaviors. And we have a framework as part of the human-centric aspect of the work that we do. We have a framework called Behavior Link, which is basically how do you use algorithms to effectively transform behaviors of users. But we're doing it not sort of like Cambridge Analytica that kind of tried to take people into a particular rabbit hole. In our case, we're doing it in the complete opposite way. We're trying to effectively move people out of a rabbit hole. Like we worked on a project with an Australian water company that they wanted to change their campaign of how they can promote water efficiency. And they realized that, telling people to have less showers or not to water their gardens was not a good idea. So we actually used AI and our models to find a different way to engage with their consumers, whereby we looked at something, well, what we described as water footprint, which is really about the water footprint of the clothes that you wear, the food that you eat, as well as your shower, as well as your gardening. And we found out through data that, in fact, your clothes, like, for example, your pair of jeans, they use something like 16,000 liters of water in production. And people didn't know that. So they've changed their campaign using this behavioral change model. So whilst changing behavior is obviously it's an ethical issue, but it can be used in the right way, and this is what we pushed for. In fact, this is why we built Nebula as an independent company. We don't want to have any influence where, our shareholders. Like I speak from experience. In my previous company, we had investors that told us, "Guys, sell the data because you can make millions out of that." I refused. I was like, "No, this is my reputation." But some people don't care about that. So for us, that's why we built Nebula the way it is now. So ethics is pretty much our number one priority. And we're pushing the idea that ethical AI actually is smarter AI. And in fact, one of the biggest, sort of the most common feedback we had with Nano, which is the reason why I'm inviting everybody to play around with it and give us feedback, that it is more engaging than ChatGPT, despite the fact it has more safeguards and sort of more ethical elements on top of it that investors would tell you that actually that would make it less intelligent or less interactive. Well, look at Nano and you tell me, is it less interactive or more? So yeah, no, pretty much everything that we work on is built on ethics.
Okay. Any questions from the audience? I have one or two other questions, but I really don't want to be the one posing questions. Okay, well, our audience is shy. So Tim, how would you go about doing a proof of concept in a mine or for a mine?
Basically, you need to effectively give us access to the data. So the way we tend to work is actually fairly simple. So we look at the problem. So what is the problem that you're trying to solve? So I think, for example, from what I've seen in the mining sector, there's a lot of scattered data all over the place. So and the most common sort of problem that people are trying to solve with the mining industry is how do we bring it all together in one place? So we would look at that first. So for us, it's really about how do we bring all the data together in a way that makes sense, and then what sort of interaction that the executive team or the engineering team, for example, would like to have with it. So it doesn't necessarily have to be with Nano. It's not. I mean, Nano is just an option, for you to be able to communicate with the data. But the key question is basically how do you bring all the data sets together into the infrastructure, and what is the ultimate outcome that you're looking for? So these are the key questions that we look for first, and then once we've got the answers to that, then we basically move forward with that.
Yeah. So doing some business analysis first, and then you're obviously assuming that there's a data strategy in that company, which you will find in many of them, not really.
I would say 99% of our project always involves data strategy, because the thing is, there's a misconception in the AI market that if you have structured data, AI will work automatically. Not really, because the reality is very simple. You could have a really, really well-structured data set, but if the algorithms don't understand the data, from the point of view of AI, your data is meaningless. So the question is, how do we optimize that? How do we make sure that the data is optimized for the AI algorithms, again, based on the solution that you're looking for? So when it comes to, for example, knowledge discovery, because it's easy, like, for example, with the Leicester University example, I mean, they didn't say, okay, just mine it and see what happens. No, they were specifically asking the question, can we identify new opportunities that we simply did not see before? And then we had to ask the question, well, what do you mean by opportunities? New funding opportunities and new interdepartmental partnerships. Great. So that gave us a target. And then we start looking at the data. We had to do a lot of pre-processing. It was very well structured, but we still had to make quite a few changes in order to answer that clear question that they had. And then through the algorithms, then they've discovered these hidden relationships between departments. So yeah, so data strategy is always sort of the #1 priority from day one. And like I said, I always advise companies that, start with the data. Don't start with the AI. I know the hype tells you that AI comes first. I'm probably the only AI entrepreneur that will tell you that AI comes last.
Okay. Well, we need some honest players.
Yeah, well, we're here.
Just trying to sell something.
We built Nebula for that reason. We want to be very transparent about that.
Thank you. Zwandile, I see your hand.
Thanks, JJ. No, I really enjoyed the discussion. I think it's quite important to really go back to the fundamentals of looking at the data. I think at the moment, as you've highlighted, everyone wants to make use of the data streams that they actually don't trust within the organization, yet they want to use AI to solve all their problems.
Yep.
So I think it's fundamental to just dispel that notion that AI will come and solve your data quality. Yeah. Thanks for those insights.
May I, because I don't want to take over too much of the time, but can I give one quick example that really highlights the point that you just made? We worked with an investment company in London. It's a fairly small company, so it's just run by ex-bankers. And they basically involved in commodities, and the way they tend to work is that they try to generate new investment leads every week. And before they approached us, they used to generate something like 5 leads per week. Each lead is worth about £50,000. So they came to us saying that, okay, we need AI to help us basically take over the search because they have to do a lot of manual searching. And they said, we feel that AI can come in, take over the searching and help us generate those 5 leads automatically. We came in, we looked at the data, and their database, or what they described as database, was something like 12,000 Excel sheets of 40 million records. And we're like, okay, here's the first thing you need to think about. Forget the AI, get rid of those Excel sheets. So what we've done, again, we looked at the data strategy. We basically done pretty much simple data migration work. So we've migrated everything from the Excel sheets to a relational database in the cloud. We've added, we didn't add any AI, just maybe a tiny bit of automation so they can search easily. And that change allowed them to generate 200 leads per week instead of 5. No AI involved. And I told the directors, guys, do you think you need AI? They're like, well, not yet. We're like, there you go. But what they have right now, so we started talking to them because they became interested in Nano. So now they're saying, well, we've got database that's already optimized for AI. Now we can get creative. But they thought initially, like you said, Jean, that they thought, AI can just take over and boom, like magic, it will just, they can just put their feet up and it will just work. No. It's always the data, always comes with the data. And you'd be surprised. I would say maybe 70-75% of the projects that we had, 100% of the customers came to us with AI, 75% of them did not need AI. And all of the projects achieved whatever they wanted to achieve. So that's kind of, the point that I always like to make, that we are, we always say AI comes last. AI is the outcome of the infrastructure that you have. If you have a poor infrastructure, the AI outcome will be very poor, no matter how amazing the algorithms are. So it's really, really important to look at the data. That's always the first point.
Right, super. And very sobering reminders there for us who get caught up. Sometimes we get caught up in the hype of technology. Tim, thank you very much, everyone, for your, and Zwandile for your question there. With that, I'd like to hand over to our next presenter. It's from a company, Ray Numeric, and it's from our presenters, Vadiraj. I hope I pronounced it correctly. Vadiraj.
Yes. Thank you so much. Yes. Thank you so much, JJ. And thanks a lot to invite us for this meeting. It's a great opportunity to come and present our solutions and technologies to you. So myself, Vadiraj Puranik, and I am the CEO and founder of Ray Numeric Simulation and Technologies. So I'm based in Bangalore, the IT capital of India. And so the way we have planned to do the meeting today is I will do the initial uh, details about the company and the technologies and solutions. I will hand over to Avinash. Avinash is our technical leader. He will cover the entire, the architecture, the platforms, the dashboards, various solutions of the digital twin and the industry 4.0. So that's how we have planned. Let me share my screen and um, I will talk through. I think the previous screen is still visible. I'm not sure if I'll be allowed to share. Okay.
There we go.
Okay, I'm just. I hope you can see my screen.
Yeah, 100%.
Okay, great. So Ray Numeric, the name as it suggests, it is the idea is to spread the numerical technologies and the digital technologies. And today we are here to talk about how Industry 4.0 can be a great solution for the entire mining application. So how we can accelerate with Industry 4.0 technologies and solutions confidently through Ray Numeric. So as you could see here, there are many kinds of sub parts or subcomponents, whether it is automation, simulation, interfaces, the data, and the entire thing, making it as a smart solution. So the way we have planned is to initially talk about various technologies, solutions, and capabilities, what we bring to the table, and how the physical and digitals are connected. At the end, I will also talk a little bit about the specific things about how Ray Numeric can add value and unique and distinct features which helps customers. That is our value proposition. Now, my colleague Avinash will talk about the entire understanding of the challenge or the problem statement that we know from Mandela mining precinct, and we are going to do a live demonstration of the user interaction, the application, entire thing to you and the committee that is present here. We will talk about the various programming languages, IIoT devices, the how the cyber physical system will work, and the enterprise integration. That is what is our plan today. Okay. The specialty about Ray Numeric is that we are known for developing and deploying the digital twins. When I meant by digital twin is it is a digital representation of a physical asset or a process or an equipment. So as you could see here, the enabling technologies for a digital twin are IoT, cloud, sensors and data, physics-informed neural network, which is based on the simulation technologies. So the entire piece constitutes a digital twin. This is a courtesy example from Udemy. So you can see here the real world and the digital worlds, how they are connected. So starting from the data that is captured from the IoT devices, various parameters that are captured, could be temperature, velocity, acceleration, any kind of a physical phenomena. And that data that comes from the IoT to the digital world, where we have a functional model, the CAD model, then those kind of data are put through across various behaviors and optimizations, so that we do a simulation, and then the for the specific outcome and behavior, we take those output of the data, and then again bring it back through edge computing to back to the physical. So the key thing is the digital twin should have a real time and automatic data flow between the digital and the real. So this is the unique and distinct thing as a concept. I wanted to just highlight this. Now, I will hand over to Avinash. So Avinash is the technical leader who has tremendous experience, and he will talk through the entire the technical aspect of the solutions, various components. And again, I will come back during last 5 to 10 minutes for more information about how we are developing success stories for the clients. So I'll just stop my presentation mode now. Oh, okay. Is it still showing or?
Yeah, it's showing a slide called Key Elements of the Real-Time Information Management System.
Right. So Vadiraj, I have shared the screen. Maybe it is my screen that is being shown.
Okay. Okay. Good. Perfect.
Okay.
Great.
Okay. Thanks Vadiraj, and thanks all the audience. In the upcoming session, I will be presenting important topics, and I will be switching between presentation and the demonstration. So I'll be running a little quick. We have short time. Basically, when it comes to the real-time information management system for mining industry, what are the key things that we need to consider? Okay, so one is the communication architecture. Let me make the pointer on just one moment. Okay, so communication architecture. So how we are going to collect the data, what sensors, what protocols, what gateways, how they will talk to servers, all those things is the communication architecture. Second is real-time equipment monitoring. So we have the equipments in the field, we have the equipments in the plant, okay, and we want to have the real-time visibility of this data, and what to do with that, we'll see that. But this is key important aspect. In the factory, we are producing the things. We want to have the real-time monitoring of the production. We want to understand where are the bottlenecks. Okay, more we understand clearly the bottlenecks, we're able to fix the things. We have the equipments. If the equipments fail, we have significant impact in terms of the uptime, in terms of the productivity, in terms of the financials. So how predictive maintenance can help? So we are going to definitely focus on that. Decarbonization. So how we can effectively use the energy. It could be electricity, it could be the gas, it could be water. So and how it can be monitored and optimized. We'll talk about using AI in various these things. We'll talk about having the unified system, how the system can be unified. We'll talk about a little bit about IoT security. We'll talk about edge processing, how it can be effective. So we have a lot of topics and we'll run through them. So this is high level communication architecture. So right, we have a set of equipments. Each of the equipment will have different parameters which will characterize their performance, their failure, okay, which will impact the failure. So first is we identify this parameter, we identify the right sensors, we deploy the right sensors. Then we will have certain gateway nodes. We'll have the communication between these sensors and the gateways. This could be wired, this could be RS485, this could be Bluetooth. Okay, so that is the strategy to decide. Then we'll have n number of gateway nodes. How do we communicate between them? So let us say we have the underground systems. So we need to have the Ethernet, or we have the other protocols, Wi-Fi, Zigbee, LoRaWAN. So which is the right protocol to have this communication? From gateway to the server. So where is the server? Is it on premise? It is on cloud. Okay. How the data reaches to them? What is the reliability of that? Okay. Then what is underneath this itself is a bigger box, and we'll talk about that. Okay. Then once the data is here, which has the real-time data, which has the analytics, which has the AI, which has the visualization, how do we have this over my various devices, which we are going to use for accessing for my laptop, for my tablet, for my mobile, for my PC, and etc. This is the whole entire paradigm. Okay, so these are the key important aspects to analyze when it comes to communication architecture. Now let us go to the next. Okay, now let us focus a little bit on this box, which is the server. Okay, and this is more shown in more detail here. So what lies in the server? So of course I'm going to show the demonstration, but let us understand a little bit more on the theoretical side. So what it has is ability to receive the data from the sensors through various protocols, HTTP, MQTT, and so on. it has certain mechanisms for signal processing. Let us say that we have the vibration data, so we need to have some signal processing. Okay, engine, we need to have it. We need to have the database. We need to have the analytics and visualization. We have to have the AI engine. We have to have the notifications and alarm. Okay, we need to have the ability to interface with other systems. It could be your ERP systems and so on. Okay, so that's what is all the IoT platform. Okay, so when we say we have the IoT platform, it has to serve all these purposes and to be reliable, efficient, user friendly, and everything. All the components should be part of this platform, right? Now let us come to so now that we have established the very high level picture, we'll go a little bit into each of these topics. So first topic is real-time equipment monitoring. We have a set of equipments, let us say on the field or in the plant. Our objective is to have the real-time monitoring of these equipments remotely, so that we have the visibility of how they are operating and their thresholds and the alarms and so on. Okay, so now let me jump into the demonstration mode now. So first is on the real-time equipment monitoring. So let us say I'll be using different roles, okay, based on what I need to show. Okay, so okay, so there are some various dashboards, okay, and we'll look at some of them. So let us say that I'm interested right now in the monitoring of equipments, okay. So then we'll have, let us say in my organization, I have compressor systems, so fire protection system, HVAC system, and so on. This is just a simple categorization, right? I will have various devices. I could have the boiler, I could have the chiller, blower, air handler, ductwork, etc. Right? Various equipments. Now, I would like to look at one of the equipment. Okay, these are some parameters of the equipment. Let us say for the chiller. Then, if there are any alarms, if there are some system components, for example, my chiller would have the motor, it might have the compressors. These are subsystems. Okay, so I would like to have the details of that. I'd like to have the alarms created for this equipment. Okay, and for chiller, there are different parameters. For example, what is my refrigerant pressure? What is my chiller water flow rate? What is my evaporator temperature, condenser temperature, compressor performance? What is my oil analysis, voltage, current, power factor, etc. Right? So which are the parameters that who decides? It's us who we decide. Okay, based on what? Based on what parameters are critical for performance, what parameters are critical for the failure. So based on that, we'll have these parameters. So we'll have the real-time data. So as the data is coming in, we'll have this. Okay, so let me again jump back into slide mode. So we'll have various equipments, we'll have the remote monitoring, and we'll have the ability to see this. Okay, now let us jump to the next one, which is the real-time production monitoring. Okay, so we are running let us say a floor which has a set of equipments, and then we need to interface with these equipments. We'll have different protocols to interface with these equipments. We'll collect the data, and we need the real-time information about the production. Okay, so when the shift is running, how the things are happening, we are interested, right? So let us assume that we have the floor, we have 20 machines, and we have interface with them. We're using various protocols, and now we have the interface. So let me log in as the production manager. So this is the production manager, and let me jump into this. So right now we are focusing a little bit on the production, right? So let us say I will be interested in, say, OE of a particular equipment to focus on. So let us say that this is my plant. Okay, I select which is my production line, which is the equipment. Okay, right now I'm in India, so you'll see some timing with respect to India. So this is 6:30. So this machine is operative since my second shift. Okay, right now it is 6:30, and okay, how it is operating when the cycle time is on, it's a green. When I have the downtimes, it is a red. Okay, then some parameters, for example, what is my target production in the shift, what is my target rate, what is my actual rate, what is the difference, what is my projected production, what is my shortfall projected based on how I'm running right now. Okay, and this is my OE. And then I will have some information, what are my top 3 downtime issues in the shift, what are my top 3 quality issues in the shift, and what are my planned versus actual, how I'm running. Okay, then I can go back to the history. Okay, I will not do that right now, we have a lot of topics, but I can go back to the history. I can say that, okay, so and so date, so and so time in the night between 3 to 4, how things are happening. I know this just based on clicks of this. Okay, I can switch to any other equipment, I see that. Okay, the real-time production monitoring. So some more things into this. Let us say that I'm interested into what is my hourly production. okay, and let us say that I define which is the number, which is the work center, and then I'll get for each of the machine, for each of the shift, okay, each of the hour, how the production has been. Okay, then I could be interested, let us say, in the let us say okay, production report. Okay, so production report, okay, for what? Okay, for in all factories or a specific plant. Okay, for let us say for Detroit plant. Okay, for particular line one, for which are the number of cells, which is the cell, for which machines. Okay, day wise or month wise. Okay, and then do I need it at plant level, or I need it at the line level or cell level or the work center level, and give me the data. Okay, the real time production, what has happened. Then I can have similarly. I'll just show some glimpse. Let us say I'm interested in the quality data, for example, that for so and so is the factory for this part. What is my production versus what is my rejection, right? So this is the quality data, and so on, many things with respect to the production. And we could be interested, let us say that to display some sort of end on screen. So let us say that this is the end on screen, and I have various, it's a like floor, big screen there, and everybody can see it. And each of these machine, how they're producing at real time, how many parts are produced, how many parts are behind, what is my OE right now. So all these things visible. Okay, and then operator interface as well. Okay, so this is a little bit glimpse of the second part, which is on the real time production monitoring. Okay, let us go to the next one, okay, which is the predictive maintenance. Okay, as we talked about predictive maintenance, basically we have the equipments. Um, it could be my motors, pumps, blowers, fans, gearboxes, special equipments, okay, or the bigger equipments. Okay, so our objective is that we identify the failure of these equipments ahead of the time. We should get the required warnings, okay, notifications, so that we are able to precisely say that okay, this is going to fail, and I get a chance to repair that. Okay, so let us jump onto this one. So let me log out as a production manager. Let me log in into the system as the uh, maintenance manager. Okay. Okay, as a maintenance manager, okay, I will be interested into seeing the assets and the performance and the detection of the pre or failure. So let us say I have these are the various plants. Okay, then within the plant I will have, let us say, production shops. It is based on how we organize the things. So let us say in this case, okay, so casting and welding, engine assembly, heat treatment, inspection, and so on. Within casting and welding, I will have some equipment. Let us say these are the motors. Okay, so this visualization will say that okay. One of the equipment is having a red, okay, it has an alarm. Okay, it will show like this the status as well. So I have the motors 1, 2, 3, 4. 1 or 2 are in the good condition, 3 is in the learning phase. We have just now deployed the hardware there, which is the device, and this is the alarm condition. Okay, I go to the details of the motor. I see, okay, these are the parameters of the equipment. For example, what is my RPM, what is my rated power, what is my bearing details, and so on. Okay, then I will have, okay, this is the no alarm, is a healthy motor, perfect. Okay, then we'll have some more theoretical analysis, physics-based analysis. Okay, so in this case, for example, we have the triaxial vibration, and we'll have the low acceleration, high acceleration. What is my time domain data, what is my frequency domain data, and I can see more details of that if I'm the vibration expert. Okay, so this data is visible to everybody, anybody. Okay, you have the access to platform, you have access to this data, right? Then you have details of the, let us say, what is my device temperature, acceleration, okay, crest factor, kurtosis value, and so on. Okay, whereas on the same lines, if I have certain equipment which is in the alarm condition, I can go to the details of that, and I will have the similar data that okay, these are the equipment parameters. Sorry, this is the motor number 4. Okay, so okay, normally you will see the alarm here. Okay, and then you will have again the analysis of this. Okay, so likewise I will have information, I will have, and of course behind this what we'll have is that two things. One is the sensor. This is the sensor that we have, which is mounted on the equipment, which is capturing the data. Okay, and then it is sending to gateway, and gateway sending to server. So all the architecture that I showed in the slide number 1 on the communication, that it is deploying. We have the AI engine behind the things, and that is its job to predict the failures. Okay, so that's a little bit on the predictive maintenance. Let me talk about the next one, which is the predictive quality. Okay, so predict what? Okay, so I'm having I'm running a production. I have for my production, I have multiple processes. I have for each of the process, I have the process parameters. Okay, and then I am collecting this data. So it is a process parameter traceability. Okay, so traceability at the plant level, right? How each of the process is running. Now I have this data. I have the quality rejection data. Okay, I use this. I build the model. Okay, so for this model, we have in the system, we have various definitions of the model that, okay, which are the algorithms to be used, how much is the data to be used, what are the parameters to be used, which process parameters to be used. So all those things are configurable. Okay. Now, once we have established all these models, okay, we allow system to build the model, okay, based on what we have defined as the data. Okay. And once it is built, okay, then we start predicting the quality failure. So what it means by that is that rather than having my production done, okay, and then identifying that, okay, so and so lot has so many challenges and I need to correct them, we are predicting the failures as things are producing. Okay, so as we are heading towards the failure, we know, okay, we are heading towards failure, and then we have a chance to look at that, we have a chance to correct the things so that we don't lose the entire lot. Okay, so that is on the predictive quality. Okay, the next one is on the decarbonization. Okay, so basically, what we are interested is that in the factory, we are consuming energy, we are electricity, we are consuming gas, we are consuming the water. Okay, so number one step. Okay, so first is how precisely I know where I'm consuming my resources and when. Okay, that is the first parameter, which is simplest thing to do. Okay, and let us first look at that first. Okay, so let me log out of this. I log in as the utility manager. Right. So we'll have various dashboards. Let us say I'm interested in the energy consumption. Okay. So I will say that, okay, which are my assets? Okay, say boiler, oven, chiller, coating, and so on. What is my consumption I'm interested? Is it a total or per unit of production? Okay. What is my duration I'm interested? This month, today, custom duration, and so on. What is my average consumption in shift one, shift two? What is my average bill? Okay. Per hour, how I'm consuming during production hours, during non-production hours. How per asset I'm consuming, per asset per shift I'm consuming. So all those details will have it. Okay, so once we have established this, we know, okay, what are the bottlenecks. That is typically phase number one. Okay, then there'll be some custom program to configure, okay, or to implement that. Okay, if I want to do the reverse thing, that is controlling my equipment based on the browser based interface, so that we can set it up remotely, the equipment. So there'll be certain ways you can optimize the energy consumption. So that comes the part number two, which is the more specific to each of the company, each of the industry. Okay, so that is a little bit on the decarbonization. Fair enough. Let's talk a little bit about the AI-based system. So basically, in the platform, we can configure what are the algorithms, supervised as well as unsupervised. We can configure what is the duration of the data, what is the, do we need to do the real-time production, or is the batch job? Okay, what are the alarms and notifications? And of course, being AI system, it will be a continuous learning system. Okay, so as we progress, its accuracy will keep on building up. Okay. Uh, Next is unified system. So we definitely would like to have the system which can absorb the data from multiple sources, which is also interfaceable, which it can invoke the APIs or the REST APIs from other systems, and also it can push the data, or somebody else can access the APIs of the system. Okay, so that interoperability, interfaceability definitely is there in the system. What are the system that I showed you right now? This is on AWS on the cloud, but definitely on premise, the same solution we can deploy on the on premise. So we have both possibilities based on the IT policies of the given organization. This is the call to be made, right? IoT security, so it's important to look at the security aspects of the things. So authentication, the access control, the encryption, do we use HTTPS? Okay, so all those aspects are important, and this is very much in place. Okay. Next is the edge computing. So this is also an important aspect. So let us talk a little bit on this, why it is important. So basically, edge computing, as we all know, that processing that happens on the device itself. So rather than having everything on the server, we can have it on the device. Okay. So of course, there are some advantages. we can optimize the rather than, let us say, sending the entire data to server, we can do the processing locally on the edge. Okay, that means we optimize on the bandwidth. We have the reduced latency. We have the real-time analysis, near real-time analysis. We have the improved reliability because we don't have the communication failures. We have the enhanced security, having the local, and we have the scalability. Okay, so all those things are there. So what it means by that is that when we let us say we talk about in one of the slide of the predictive maintenance, I talked about, let me go back a little bit. I talked about this device, which is, we call it as the X predictor. Okay, so this has the microcontroller, so that means all the processing that we can do it here. And likewise, in the microcontroller, we do all the processing, and hence there onwards we can optimize the processing. Okay, okay. So some just a glimpse of various dashboards and okay, platform capabilities. I talked about the on-premise as well as on-cloud, highly scalable. We can have a number of devices up to 10,000. They can send the data with very high frequency. We can have the real-time analysis. Okay, we can have the asset hierarchy as we want. I showed some hierarchy during the demo, but we can organize how we want it to be. That the alerts and notifications on say emails and WhatsApp and so on. Integration with the ERPs or the maintenance systems or any other systems. Right. Okay. So that's on the technical front. So Vidiraj, over to you.
Yeah, sure. Let me share. Thanks so much, Avinash. Yeah, it was a great talk, and then I think you have explained all the different components very clearly. So we can take maybe questions once my slides, a couple of slides are over. Is my screen visible?
Yeah. Yeah, it's visible.
Okay.
Says
Sure.
what next?
So, right now, I think this question is to seek and understand from you, how do we proceed further? So our thinking is that we would like to understand, the kind of, the inputs that you already have, and collect these data and details from you to know where are the sensors, what are the processes, who are the people, and then, how is the data, all these things, and understand more about the problem description and the details that you have probably, and how you want this to be further executed, and what kind of accuracy timelines you have, how do you want to devise the architecture and this plan on cloud or on premises and so on. So we would also plan to visit the site and where the location, for example, and then meet all the relevant stakeholders, and then understand in-depth technical discussions with them to come up with a more approach and plan and execution plan with kind of timelines and cost estimations and so on, and then make a techno commercial proposal to you, and to get the sign off and further move further on the commercials also. So this is what we thought could be possible steps to engage further and collaborate further. Just to talk about a little bit about what is our guiding principle, what is the motto and purpose we have. So we want to be best in class provider of a digitalization software and services company. We started in 2017, and last more than 5 years, we have been serving customers in various industries and domains. On a day-to-day basis, we are always constantly looking to come up with innovative solutions to various business problems the client give us, whether it is on a software basis or a project basis. And then some of the unique non-negotiable or core values we stand within employees, partners, customers are excellence, respect, integrity, learning, and commitment. So this is something core of our company. So thought of informing you, and then understanding, making it better clarity for everybody. So how we have been successful in delivering this kind of a value and building a long-term customer relationship is because of this value proposition. So this is what it talks about. Basically, innovation, as I mentioned, is the key thing to talk about. We have proven techniques and rich experience in simulation, in digital technologies, as Avinash and I have talked about throughout. And then cost efficiency, we are focused on Industry 4 and CAE, which is computer-aided engineering. This is a focus for us. The solution and technologies that we develop are highly customizable. Automation and optimizations are very easy. Lower overheads, since we are a startup. So the overall total cost of ownership to the client is less. We have established a multidisciplinary ecosystem which encompasses different disciplines, whether it is sensor, whether it is AI and machine learning model, whether it is big data, cloud computing, physics-based simulations. So we have built a system wherein this kind of a multidiscipline talk to each other, and ultimately the customer enjoys this kind of a digital twin benefit. So then myself and Avinash will be point of client conversations, and there is a complete alignment to the client goals. We are committed to the success of the customer, whatever goals we define, and then transparently define the entire plan and get an agreement. And as I mentioned, the solutions are highly customizable, and we can build from the platform, or if you have already some solution already developed, we can build on top of it. So that is the unique thing. These are 5 indicators I wanted to talk about. This is a slide which talks about various customers we have in our portfolio. As you could see here, automotive, aerospace, manufacturing, energy, electric vehicles, engineering services companies are our key clients. Just to talk about more on the process and mining side, as you could see here, JSW Steel is there, Armstrong, which is a pump manufacturing company, and then Dover, which is a Earth Environmental Solutions group company, and then Schenck Process for various conveyors and bulk material handling equipments. Grace is a chemical company, and then similarly Valdel for various engineering, procurement, and construction applications, EPC, Schneider and Tata Steel for steel manufacturing. So WME for construction and architecture, AEC group category. So this is the flair of the clients we have, and we have worked with various international clients of global reputation. Yeah, I think that's it for the day, and I hope we are within time, and we're open to questions actually now, JJ and the team from MMP.
Great, thank you, Vadiraj and Avinash. Yeah, I think you just emphasized the fact that IoT is it's holistic, it's integrated. You've got to think of all those different components and apply best practice to each of those. I don't know. I don't see any questions from the audience. There's one from Nzwandile, Zand.
Yeah, sure.
Thanks, JJ. I think my question is related to if you look at the complexity in terms of number of equipment. I think you've taken one piece of kit and you really showed in-depth analysis on it. If one had to start this journey, what is the best advice or best way to go ahead in terms of adopting, the platforms that you're talking about? Because it's quite broad and very granular, which makes it quite daunting.
Okay. So to start with using the platform, it looks a lot of functionalities there, but what to use is something that it's on us. Okay, so let us say that our first criteria is have the real-time monitoring and the predictive maintenance. If that is the key thing, very simple. Create the devices, add the sensors, have the gateway, have the communication, and rest of the things are configurable. For example, algorithms and everything are in place. Okay, that means we just create the devices, we put up the sensors, the sensor starts sending the data, and that's all. Okay, we have all the things in place. Okay, so within a month, within a couple of months, you should have your predictive maintenance use case running up and fine. Let us say the second case is that you are more interested into decarbonization. Okay, where you are interested in the energy monitoring. Okay, yes, fair enough. So we need to identify, okay, this is the plant, these are the equipments, these are the energy meters we need to interface with it. So some assessment of your devices will be done to identify how do we interface with them, which are the gateways needed, what are the protocols needed. Okay, and that's it. Okay, within a couple of months, we have all the data, energy data coming in, all the dashboards are already built in. Okay, and of course there is any customization that you need, that is additional. Okay, but you get what I showed to you, you get it just like that. Okay, to start with within a couple of days. So so likewise, we need to first identify what are the key business benefits that we are interested into. We take that use case, have the configuration, have the solution, have the business value, then we take up the second. Okay, so I just showed it because it's also important to visualize everything, so that your platform, what you choose today, okay, should be capable of serving you after 5 years, right? More. And so I just showed you some modules, and we can add more and more modules, which we are anyway doing it. Okay, so likewise, it is important to first think what all things I would need it in the longer term. I need AI, I need real-time visibility, I need, okay, so the security, those should be in place on day one. Then, okay, what to use it, we take a small piece, we implement that, we go from there. Okay, so hope that answers the question.
Yeah, no, thanks for that.
Okay, thank you.
Yeah. So just a question observation from my side. Slide 6, you mentioned, if you go back to slide 6, you'll see you mentioned open source.
Okay.
Why open source?
Okay. So when we say open source, we are using, for example, if when you talk about the AIML, okay, so all those technologies that we use it are actually open source. Okay, so we have all the Python engines, and we can use it. Okay, or for front end, whatever we have built it, or the database that we have built it. Okay, so it is also open source. Okay, so we don't have any vendor lock-in. That means there is no licensing control. Okay, and second thing is that, let us say that it is not something that only we can build it. Okay, so let us say that we work with a company, and you have your own development team. So we can have small session how to create the widgets and so on, and you start extending the application. Okay, so you can take it from here and you can extend it, and we can support you in doing that. So likewise, it is easy to extend, and plus there is no licensing tightness or AI. Let us say that we are not using AWS algorithms, so that we are so tightly coupled that we cannot have it on the on premise. Okay, so all those flexibilities we have already taken care. Okay, so that's what we mean. It is open and interfaceable, and no vendor lock-in.
How do you cater for environments where you have the traditional, typical SCADA kind of environment? How do you deal with that?
Right. So basically, we need to define the architecture. For example, where the data is going to come in. Okay, so there are two possibilities. One is that we have sensors, we have PLC, and let us say we use Profinet, Profibus, get the data from these PLCs and send it to server. Okay, that's very much possible. Okay, in case, and that's the very normal thing. Okay, second case is that let us say you have some equipment which is outside, let us say on the site. Okay, so there, okay, we put some certain sensors, and we might use Bluetooth. Okay, because there is no there is no PLC there. Okay, so we can use Bluetooth, we can send the over Wi-Fi, or we can use the gateway which is the LT4G kind of gateway. We can use that. Or in the third case, if you have all the data in your SCADA already and you're sticky with that, okay, then we need to have a custom project wherein we need to push the data from the existing SCADA to our server. Okay, so that is something that can come as an additional custom module. We need to have it. Okay, based on which SCADA that you're using, and that's how it needs to happen. So we need to define, to discuss a little bit more what are the possibilities are there, what is the most optimal architecture is there, and then we go from there.
Okay, good. That's it from my side. I don't have any comments or questions. I don't see anything else from the audience. Thank you very much for the presenters today. So
yeah, thank you so much, JJ, and all the team members. Thanks so much.
Thank you very much.
Good. With that, like to bid everyone goodbye. Stay safe. And feel free to reach out to our presenters. And I'm speaking to the audience now. Feel free to reach out to the presenters and get more information from them. We will share the presentations as well as their contact details, so that you can engage further if you like. Thank you, everyone.
Great.
Have a good
Thank
day.
you so much. Thank you. Bye-bye.
Thanks, sir.
Bye.
Thank you.
Bye. Thank you. Bye.